and thank you for joining Converged Database from REST to Relational session. Some housekeeping reminders during this webinar. All lines are muted, so feel free to use the Q&A button to ask your questions. For any topics you would like us to cover, just let us know. This webinar will begin 3 minutes past 11 as we hold for all participants to successfully join. For any further information, don't hesitate to contact us at the email address that we have in place, contact-dcx-emia_ww@oracle.com. So let's wait 3 more minutes so that everyone can successfully join. Hello, everyone, and thank you for joining the Converged DB session today. Before we do get started, I would like to emphasize today's safe harbor statement, and for all the sessions that we host, either educational or onboarding ones, the main purpose of them generally be educational and informative, and of course to showcase a few things about Oracle, but please bear in mind that you shouldn't do any purchasing decisions based on what we cover today. With no further ado, I would like to present some of the session takeaways and asks. So we offer a recording of the session or a copy of the slides. By the way, this session will be also recorded. If you need assistance, you have the Q&A button to ask your questions, which we are going to take at the end of the session. If there is a specific topic you would like us to cover, just let us know. And of course, don't miss the live demo into the Cloud Console. So if you already have an Oracle Cloud account, just log in and take this journey with us. For any further information, you may contact us at the email address stated here, contact-dcx-emia_ww@oracle.com. With no further ado, I would like to present today's speakers and panelists. I'm one of them. I'm Violeta. I'm a program delivery specialist within GCE organization. I'm based in Bucharest. And today I'm joined by a more technical colleague of mine, Roxana, who will actually walk you through the main topic, which is about a Converged DB. Before we do get started, I would like to present the cloud engineers team that we represent today that are here to aid and support your cloud journey. One of the points of contact that we have with Oracle, the cloud engineers team are mainly to work as a connector with different teams and services within Oracle. And they are here to help you to treat and to deal with our cloud infrastructure technology. And of course, to get you more familiar with our cloud technology. For any further questions or information, you may contact us at the email address that we have in place. Now it's time to hit the presentation, to start the presentation, and I will hand over to my colleague Roxana. Roxana, hand over to you now, and enjoy the session.
Thank you, Violeta. Hello, everyone. My name is Roxana Popa. I'm a senior cloud specialist, part of data management team in Oracle. And today I'm going to talk about our Oracle Converged database. What does Converged database mean, and some of its features. And after the presentation, I will show you a live demo and showcase some of the features and how they work together. If you have questions during the presentation, please feel free to post them in the Q&A section, and I will take them from there. Let me start sharing the screen. Okay, let me open the presentation and proceed. The best way for a business to maintain their competitive edge is understand their customers' needs and to quickly deliver value to those customers. The key to this is to take advantage of data-driven applications, which allow you to understand and creating value from your data. A good example here would be how responsive and portable a food application delivery might be. The mission-critical databases have been complex for decades, and data has become more and more important over the years. Enterprises have to create unique data assets and make the most of them to remain competitive. But as companies create more applications, analytics, and artificial intelligence to have more process digitized, the databases become more and more complex. And here I'm referring to the possibility to have real-time analytics, to have a scale-out architecture, zero downtime, and of course, security. Decades of automation plus the addition of cloud and machine learning have enabled Oracle to eliminate database management complexity. As we know, modern applications require many different data types. For example, we have relational data, documents, spatial, graph, and many different workloads. Transaction, analytics, machine learning, and IoT. And here we have two possible data strategies. Either to use a single-purpose best-of-breed database for each data type and workload, but of course this will require more integration work, or we can use a converged database to cover all the data types and workloads. Basically, this has led modern application developers to break up this monolithic application into discrete distributed components and have a separate service for each core business capability, with each service having its own database. While this approach provides functional isolation, which means each service can be modified without disrupting others, and each development team can use their preferred development language, it provides data encapsulation, allowing each team to control their data. But integrating fragmented databases to create a complete, available, and scalable solution is complex and custom. We are facing fragmentation on different areas, on development, on management, on data consistency and security, on availability and scalability, and of course on cross-site consistency. The issue here is that while the goal is to add value by adding workloads, you can actually end up with an exponential increase in complexity, which ends up getting in the way of the original objective to be data-driven. And each single-purpose database requires unique management and skills. If we are talking about development fragmentation, for example, the single-purpose databases require applications to use their proprietary APIs and transaction models instead of standards open like SQL. It fragments development, it locks in the application to the single-purpose database, and it is dramatically simpler for developers to invoke declarative SQL to run machine learning, graph, IoT, spatial, and everything in one converged database, instead of implementing multiple fragmented databases. If we are talking about data consistency fragmentation, we must continually transform data and propagate changes between applications and between single-purpose databases, and this is really difficult to do. About data security, each single-purpose database has a different security model. So we must separately implement security policy in every database and re-implement them in every database when application or policies change. So we waste a lot of time here. About availability and scalability, because this is really important, we must make each single purpose database highly available and scalable using mechanisms specific to each product that we have. So integrating single-purpose databases is a job that never ends, and systems integration is custom built. You must continuously reintegrate, retune, troubleshoot, and so on. The issue is not having the data. Everyone can easily collect data. The issue is how you turn the data into insights to drive your business forward. So let's see how can Oracle's Converged database can help here. I mentioned the Converged database term. So what is Converged database? Is a database that has native support for all modern data types and the latest development paradigms built into one single product. Oracle Converged database is multimodal, multi-workload, and multi-tenant. If we take them one by one, multimodal means that with Oracle database, we provide one single converged database that converges all these different kinds of data types or data model into one single engine. And the reason why we do this is because it makes the application much more efficient. As I said, Converged databases support spatial data for location awareness, Json for storing documents, IoT for device integration, we have in-memory technology for real-time analytics, and of course we have traditional relational data. Multi-workload. Oracle database supports different kinds of workloads. We support data warehouse, transaction processing, IoT, and so on. A wide array of software optimization that work alone or together to deliver exceptional price for performance across all types of database jobs. So this makes it easy for developers, analysts to know how to use Oracle for different types of workloads. And the bottom line here is that Converged Open SQL database makes developer more productive. And the fact that is using SQL is important because, as we know, SQL is an open standard, which means that we can build applications and we don't feel like we are getting locked in because we are using an open standard. And if we want to move to other SQL databases, it's really easy to do this. Another powerful technology that we are using here is multi-tenant architecture. The database container architecture provides database consolidation, isolation, and agility. This is just part of the Oracle database, so you don't need to do anything about it. And it gives the developers the ability to somehow virtualize the database into a large number of database containers. I already mentioned some of the benefits that this Converged database brings to the developers, analysts, and operations teams. Some of them are that it supports mixing of workloads, data types, and algorithms, as I already mentioned. It provides unified security and management. It prevents data fragmentation and copy contagion, and most important, it removes the integration cost. You will also get synergy across these capabilities. For example, by having support for machine learning algorithms and spatial data in the same database, you can easily do predictive analytics on spatial data, making it easier and faster to develop data-driven application. You can also detect fraud in real time by applying machine learning. You can build flexible OLTP data models by leveraging document data types. You can achieve high concurrency and security for your data warehouse. You can run real-time analysis on data streaming into your document store, and of course, boost the spatial application with social graphics and real-time updates. And what it's important here is that you can access the data via SQL and REST or using model-specific APIs. So you have two options here. You either use a cross-model data access using SQL and REST for many data types like relational, graph, document, spatial, multidimensional, and so on. Or you have the option to use a model-specific data access. So for example, we have Soda that has pre-built REST APIs for JSON. You have property graph, RDF graph, and so on. I already mentioned some of Converged features of Oracle database, but if I will recap them, the first one will be multi-tenant for efficient and agile database cloud. in memory for database acceleration. If we want hyperscale and geo-distribution, we have sharding. We have native support for JSON, and I will show you after the presentation, I will show you a short demo on how to work with JSON data in a relational way. We have blockchain tables for preventing fraud, spatial and graph, and for low-code development, for example, we have Apex and REST services and many others. I will briefly talk about some of these features. Oracle enables microservices to be developed as if each had their own independent database, while avoiding the integration complexity of deploying many databases. The separation of databases is enabled by using the multi-tenancy feature. And as I already mentioned about multi-tenancy, we have multiple pluggable databases that you can move them dynamically between physical container databases. As part of Converged database features, we also have blockchain tables. You may wonder why to use a blockchain table, because it enables a neutral party who can act as the central authority and to secure existing application. Is the easiest way to uptake the blockchain technology. It integrates blockchain algorithms to help identify and prevent fraud. And yeah, what is blockchain table? Basically, it's a highly temper-resistant persistent option in Oracle database that is available in cloud or in Oracle database 21. Some common attributes of blockchain table: you can only append data. The inserted rows are cryptographically chained, and the chain can be verified and signed by participants. Some use cases where you can use blockchain table, you can use it as complementary to blockchain platform for secure offline data store. You can maintain a centralized immutable transaction log or audit trail and store compliance data. You can use it for records for financial tables, legal hold data, and many other examples. Document data, and this part will be shown after the presentation. Oracle database supports JSON data natively with relational database features. And here we can include transactions, indexing, queries, and views. Basically, Oracle database provides all of the benefits of SQL and relational database to JSON data. You can store it and manipulate it in the same way and with the same confidence as any other data type in the database. You can use SQL to join JSON data with relational data. You can project JSON data relationally, making it available for relational processes and tools, and I will show you how to do this. You can also query from within the database JSON data that is stored outside the Oracle database in an external table. So basically, you will see that you can access JSON data stored in database the same way you access any other database data. Spatial and graph. Spatial is included in Oracle's Converged database. It allows developers and analysts to get started easily with location intelligence analytics and mapping services. And it enables GIS professionals to successfully deploy advanced geospatial applications. By using spatial data, you can define points, polygons, lines. You can compute lengths, area, and distance. You can query relationship between geometries. For example, if I want to see if there is a residence located with a mile of the area we are planning to build a building, we can use spatial. And it has a lot of advantages. You can efficiently process spatial data types, and it supports a wide range of applications. About graph data, this is also part of Converged database offering, and it eliminates the need to set up a separate database and move the data. For example, analysts and developers can perform fraud detection in banking, can find connections and link to data, and can improve traceability, all while gaining enterprise-grade security and ease of data ingestion. We also have Oracle Apex for responsive web and mobile application. So if you wonder what is Apex, this is a low-code development platform that enables you to build scalable and secure enterprise application with world-class features that can be deployed anywhere. Using Apex, you can easily develop responsive and database-driven application using only your web browser. So you don't need anything installed on your local machine, you just need a web browser. You can have it either on-premise or in the cloud. Just using your web browser, you can quickly build reports, forms, charts on top of the data that you already have in the database. Also, Apex enables you to capitalize the existing investment that you have in SQL and PL/SQL skills, and few programming skills are required here. So anyone can quickly learn to develop application fast. What I want to add about Apex is that it's a feature of the Oracle database with no licensing costs for development or deployment. If you have Oracle database, you already have Oracle Application Express. And on top of this, we have a huge developer community that is there to help and support you. The last feature that I will talk about is Oracle REST Data Services, or ORDS. This is a secure performant HTTPS access for your Oracle database. It's a mid-tier Java application, and it provides a database management REST API and the ability to publish RESTful web services for interacting with the data that is stored in your Oracle database. And we will see on the demo part how to easily do this. Using ORDS, you can access your data via HTTPS. And we have several methods. For example, if we want to access the data in store procedure, we have the get method. If we want to update the data, we have the put method. To insert the data or execute the PL/SQL procedure, we have the post method. And to remove the data, we have the delete method. So basically, you can use your favorite protocol and your favorite data format. In conclusion, now IT has been costly and slow for decades, and the root cause for this is complexity. New approaches can finally eliminate the source of complexity, and having autonomous management, cloud, and machine learning eliminate the complexity of enterprise products. A converged product with all needed features eliminates the complexity of systems integration. Okay, next I'm going to show you a short demo. The first part will be how to work with JSON data, and here we are going to see how to insert JSON data in a table in Oracle database, how to update JSON data with SQL, and how to query the data. And then, as I mentioned during the presentation, we will convert some documents to relational, and we are going to do this with JSON data guide. And the other way around, we will expose the relational data in JSON format. And after that, we will take advantage of ORDS to create some RESTful services for the data that we create on the first part. And we will see how to retrieve, insert, update, and delete the data. Before jumping into the demo, I will like to share with you some useful links. The first one is about Oracle's Converged database, how to make developers and data more productive. And then the JSON developers guide if you want to have the documentation of what I will show you today. The links for Oracle Spatial, Oracle Graph, the Apex primary site, and the documentation for REST services. Okay, now let me start the demo. I will use an autonomous database for today. A great example of Converged database is our Oracle Autonomous Database. For this, I prepare a schema, app.json, and we are going to use the table purchase order today that has 3 columns, one that stores the ID, the date when the data was loaded, and the PO document, where the PO document is JSON data. Okay, and now let's start by inserting JSON data in a table. I have prepared some scripts for this. First, let's see how many rows I have in my table, in my purchase order table. Okay, I have 10,010. Let me put something like this. And let's see how easy it is to insert data. So as you can see here, this is a regular SQL statement. I'm going to insert into purchase order table the following values. This is to generate a unique ID. This is a date. And here it comes the data that is in JSON format, as you can see. So nothing special here. You can see that one row was inserted. If I go back, here we have this function, JSON serialize, that will print in a pretty format the JSON output. It takes as argument the column where the JSON data is stored, and we will see our data. Okay, here is the data that we have. If we want to see in a nice format, we need to use a run script. Okay, so this is the data that I have just inserted. Now, if I want to update this data, let me select an ID. I will take this one. This is the row that I have just inserted. You can see here that I'm using an update statement, and I will set the PO document. This is the column where the JSON data is stored. And here I have the JSON merge patch. This is an Oracle SQL function that comes out of the box and is used to update a specific portion of a JSON document. We have to provide the JSON merge patch document that specifies the changes that we want to make to a specified JSON document. So for this document, I want to update just the requester. You can see that now it's Sarah Bell. And after I run this script using JSON merge patch, you will see that the requester has been updated. Okay. We have seen how to insert, how to update. Now let's see how to query the data. The first example, Oracle Database SQL Engine allows you to use a simple dot notation access syntax directly on your JSON data. So you can write SQL queries that contain something like this. I have defined an alias here for my table. And I have the table alias, the JSON column, and here I have several JSON properties, and I can add here as many as I have in my document. I can use this syntax on both the select part and where clause. So if I want to find all the customers who order products from this specific city, South San Francisco, I just use this simple dot notation access. If I run this, you will see that the result is in a relational format, in a table view. Okay. Another way of querying the data is to search for attributes. So if I want to find all the customers who purchased an item that is tagged with this specific UPC code, for example, I have this JSON exist operator. This is used in the where part of the query. Is used to test whether or not the JSON document contains content that matches the provided JSON path expression. As you can see, it takes two arguments. The first one is the JSON column, your document in our case, and the second one is a JSON path expression that should be equal to this code in my case. Now, it returns true if the document contains a key that matches these values, or false otherwise. And you may notice that in the select part, I'm using the simple dot notation syntax. So here is our result, again in a relational format, in a table view format. Now, let's say I want to find the customers who purchased the specific products based on the description of the product. For this, I can use JSON table. This operator uses a set of JSON path expression to map content from a JSON document into columns in the view. Once the contents of the JSON documents have been exposed as columns, you can use the power of SQL to manipulate the data. So as you can see here, as arguments, I have the column where the JSON data is stored, and here I'm defining the column. So I want your number to be number, and here I need to define the path. For reference, go to reference, and so on. I can even have nested path. So for line items, I want the item number, and I want the description, again is a nested path. I want the UPC code, quantity, and unit price. And what is great about this is that once I define the columns and I map them to JSON path expression, I can even add a condition based on the columns defined. If I run this, you will see again the data in a table view format. So it's really easy to manipulate it and to read it and work with it. Okay. I mentioned in the presentation that we can convert documents to relational using JSON data guide. This function, JSON data guides, takes a table column of JSON data as input and returns the data guide as a CLOV. You may see that I defined here a variable, and I'm saving the output of the JSON data guide into this variable. You may see here that I'm using a DBMS JSON format hierarchical option. If you want to specify the format of the data guide, you may use either hierarchical for hierarchical structure or format flat for a flat structure. And then the next step will be to create a view. And for this, I'm going to use again the package dbms JSON. Basically, this package provides you many subprograms for manipulating JSON data. So you already have it in the database. And I have this create view procedure that creates a view with relational columns and scalar JSON fields as specified in the data guide. And as arguments, you can see that I have the name of the view that I want to create, the source table, the JSON column, and the data guide. I will just run this more code, and you will see how my view looks like. Basically, I converted JSON in a relational format. If I want to expose the relational data in JSON format, I can do this using Json Object. This Json Object function takes as its input one or more property key value pairs, and it returns a JSON object that contains an object member for each of those key value pairs. So I have for this key PO number, I have this PO number, and I will define as many key values as I need. This is how the result looks like. So it converted, if I will show you the data from this one. Okay, you may see that it's in a relational format, and once I use the JSON object function, you will see it in a JSON format. If I want to convert all the columns, because you may see that here I converted only some of them, I can simply use JSON object and all columns here, and it will convert me all the columns into JSON properties. Okay. As I mentioned, we have interfaces such as REST that allow for easy communication and integration with Oracle database. So this will bring me to the second part of the demo, where I will define some RESTful services for my app.json schema. And for this, I need first to auto-rest enable my schema. To auto-rest enable my table, I will use the same table because I just want to show you how you can work with many data types and many services without the need of integrating them manually. So I'm using the same database. Okay, to auto-rest enable the schema, you can do this by using many tools. So for example, you can use Oracle SQL developers that provides a nice wizard to do this. You can write your SQL code and use the procedure provided by Oracle. You can use Oracle Apex to do this, so you have several options. But for today, I'm going to use SQL developer. So I just need to right-click on my application schema, and I have here REST services. And all I need to do is to click on Enable REST Services. The RESTful Services wizard will pop up, and here I have this Enable schema that I need to check in order to make it REST enable. I need to provide the schema alias, and this alias gives the names that is used in the REST URL to access the object. And for this demo, I will uncheck this authorization required, because if it said only authenticated users having this role, Oracle DB Tools role auto-rest app JSON may access the object. So for the demo purpose, I will just uncheck. I will click on next, and that's it. You will see here a summary. If you want to see the code behind this, you can click on SQL, and you will see that ORDS enable schema procedure is used. Click on finish, and that's it. The next step will be to REST enable the table, our table purchase order. In the same way, I will right click on it and I have enabled the service. I will check the enable object box. I will leave the default object alias, and I will not use authorization for the demo. Again, I can see the SQL behind. I'm using ORDS enable object procedure and click on finish. And that's it. Now we are ready. I mentioned here, when using RESTful services, the data is modeled as a set of resources. And these resources are identified by universal resource identifiers. And I'm going to show you in a few seconds. So in order to manipulate these resources, we need to define a set of operations. We need to define a resource module, a template, and a handler. So to do this, again, we have several options, but today I'm going to use SQL Developer. We have, if you scroll down here, we have REST data services. If I expand this, I have modules. And to create a new module, I need to right click on it and new module. I need to give here a name, let's say CMVG. And here I need to put a universal resource identifier that I mentioned. Let's say again CMVG. And you can see as I'm typing here the URI prefix, the link is being built up. And what is important is to check this box to publish the service to be available for use. If you don't check it, you will not be able to use the service. Next, I need to define a template, a pattern. So let's say I want to access only a specific row, a specific document. I can use a bind variable here, for example, ID. And click on next. You will see that the link is even longer now. It has the ID added here. If you want to see the SQL behind, you can click on SQL and you will see the code to define a module and the template. Then click on finish. Okay, now that we have the module and the template, if we want to retrieve the information from purchase order table, we can do this by using the get method. And let me create one. Right click on the template, add handler and get. Here the source type can be, you have many options for this, but I'm going to use the default collection query and click on apply. And you will see here the SQL worksheet that comes up. And here I need to put the SQL that will run once you access this service. So I will do a select where here I'm using the simple dot notation syntax, where pure number is my ID. I can even test this. Here you add a value that you know that you have in your Oracle database, click on apply, and you will see the result. If this is what I want to see, I will click on save. Now, in order to test the service, we can use a web browser, for example, and paste here the link. As I mentioned, let me hide the controls. I'm using an autonomous database, so ORDS comes already pre-installed and pre-configured. So I don't need to do anything else. I can just start running my service. Okay, and you can see my data here, search by this ID. If I want to retrieve all the data, I need to add a new template, and this template will be CMVG. And to retrieve all the data, I will define a new handler here, a get method, and the select will be Much easier this time. I will just select all the data in my table. Now that I have defined this method, if I remove this ID from here, I will be able to see all the documents in my database. If I want to insert data, I can do this by simply define a post method. I will click on apply, and here I need to add the code to insert the data. This is just standard simple SQL code. I will insert into this table. The values is exactly the same that we have seen before. To test this, we can use, for example, Postman. And here, we need to enter the request URL, which is this one in my case. We need to choose the method, which will be post. If I want to insert, it means that I need to provide some data. So I will choose body, it will be raw data, and here you have the selector and select JSON data. And now I need to provide some JSON data. Okay, and click on send. If you see here the status 200, it means that the request was successful. Now we can check the data that we inserted. I will just take this PO number and go back to my browser and put it here. Okay, and I can see my data is here and is ready to use. In the same way, if I want to update the requester, now it's Arabelle, I can define a put method. I will use this template because I want to update just a document, not all of the records. So add handler put, and here I need to provide the clear SQL code. I'm going to use again JSON merge patch and click on save. If I return on my Postman, I will select again the PO number. I will put it here in the URL. I'm going to select the put method, and I don't want to update everything, but just the requester. If I put it here and click on send and go back to my browser and refresh, you will see that the requester has been updated with this done user. And the last part of the demo is how to delete this data. And for this, I'm going to create a new method, delete, again, just for one document, click apply, and I will just put the code here. Delete from my table where my PO number is this one. Click on save. And if I go back to my Postman, the link is okay because I want to delete this specific document. I just need to choose from here the delete method. I don't have anybody here. And click on send. And you will see the status is 200. Okay. If I go back to my browser and refresh it, you will see that I don't have any data here. Okay, so this is what I wanted to show you today. If you have any questions, I will be more than happy to answer them. If not, thanks a lot for taking the time, and I hope you enjoyed the demo and the presentation.
Thanks a lot, Roxana. Guys, before we hit the Q&A part, I would like to show my screen again and present some useful resources that you may use. Okay. So just to wrap up for everyone in the call, there are two handy resources that you may use. First one is our Cloud Coaching Clinics portal, where you can go to register for any upcoming events. By the way, we host events on a weekly basis, so do keep an eye on the schedule. And the second resource is the Oracle Video Hub. We're actually going to attach all the recordings of the sessions that we host. Next week's event are about what's new at Oracle Cloud. So we will present the latest dedicated product updates of the month. And the first week of July, we will be hosting the Oracle Cloud Cost Control and Budget Monitoring session. And of course, some other useful links that Roxana already mentioned, and some more regarding the OCI documentation. And before we move on to the last part, I would like to launch 3 simple questions that we kindly ask you to answer. So I will leave you like, I don't know, 1 or 2 minutes to answer them, and then we can go directly to the Q&A part. Thanks a lot for your answers. I will share the results a bit later. I want to assure you that your answers are very valuable to us because they will help us improve our work. And now it's time to Q&A. So if you have any questions, don't be shy and just put them in the Q&A button, and Roxana will answer them. So we have a question from Rafael. How will you perform value calculations in this format? Is it possible? Will you answer live, Roxana?
Yes, it should be possible. In the same way you convert them to relational, and then you can perform the calculations that you need.
Hope this answered your question. Any other questions?
Violet, if I could just add one thing.
Yeah.
In July, the registration page will be appearing this week, I'd say. There will be an Apex, another session on Apex. It's kind of third part of a series of events we run on Apex. So if people are on the call are interested in Apex, Roxana mentioned it on her session, there will be more training delivered on that in July. So just watch the links that Violet delivered.
Thanks a lot for completing, Tom. Well, if no further questions, I would propose this meeting to an end, and I would like to thank you all for joining our session, and to say a big thank you to Roxana as well for presenting and for the cool demo that you did. And we are waiting for you on future webinars. Thanks a lot.